Hi there, and welcome to today's video. Today, we will be learning about two very important topics in math, ratios and proportions. We'll define what ratios and proportions are, look at some examples, and learn where we might see them in our daily lives. Let's get started. In mathematics, we use something called a ratio to show how big or small a number or amount is when compared to another. When we use a ratio, we write the two numbers with a colon in between them, just like this. This is read as A to B, and it shows how big or small the number A is when compared to B. As an example, think about 5 blocks of two different colors. Out of the 5 blocks, 3 are yellow and 2 are blue. So the ratio of yellow blocks to blue blocks is 3 to 2. Ratios can be written in 3 different ways. We can use a colon to separate the numbers. This is the most common representation of a ratio and the same as the one we just looked at. We can use the word 2 instead of a colon, or we can write it in the form of a fraction. The colon and the line in a fraction are sometimes used interchangeably, so 3 to 2 can also be written as 3 over 2. It's important to always write the numbers in the ratio in the order that they are compared. Let's look back at our yellow and blue blocks. The ratio of yellow to blue is 3 to 2, but if we were to write the ratio of blue to yellow, it would be 2 to 3. The two ratios are not the same because the order in which the colors are compared is different. This is a common mistake, so be sure to pay attention to the order of the ratio the problem is asking for. Now that we know how to write ratios, let's use them to practice comparing things. There are 2 ways to compare quantities using ratios. The first one is a part-to-part ratio. The part-to-part ratio shows how 2 separate quantities are related. That is, how much bigger or smaller one is than the other. Remember our colored blocks example? This is a part-to-part ratio because we are comparing 2 separate parts to this group of 5 blocks, the yellow part and the blue part, with each other. The ratio of blue to yellow blocks is 2 to 3, and the ratio of yellow to blue is 3 to 2. This shows that there are fewer blue blocks than yellow blocks. The second way to compare quantities is the part-to-whole ratio. The part-to-whole ratio shows how one part compares to the whole group. Here, there are 3 yellow and 2 blue blocks, giving us a total of 5 blocks in the group. This means that the ratio of yellow blocks to the total number of blocks is 3 to 5. And the ratio of blue blocks to the total number of blocks is 2 to 5. Now, let's take a look at some ways to simplify ratios. When writing ratios, you might come across a pair of numbers that can be simplified, meaning they can be represented using smaller numbers. It is important to simplify ratios because just like fractions, they are easier to understand when we use smaller numbers. To reduce or simplify a fraction or ratio, we look at the greatest common factor, also called the GCF, of the numerator and the denominator. Let's use an example to see how we can simplify ratios. Bonnie is playing with 8 marbles. 2 of the marbles are pink and 6 of them are green. The ratio of pink to green marbles is 2, the number of pink marbles, to 6, the number of green marbles. As a fraction, this can be written as 2 over 6. What do you notice about this fraction? You might be able to tell that it can be simplified and written using smaller numbers. We know this because both 2 and 6 can be reduced by a common factor, which is 2. So, we can divide them both by 2, which gives us the fraction 1 over 3. In ratio form, this can be written as 1 to 3. Keep in mind that simplifying a ratio does not change how the quantities compare to each other. we should always simplify ratios as much as possible. If the numbers have no common factors and we can't simplify the ratio, then we can leave it as it is. Simplification makes a ratio smaller. If required, we can always make a ratio bigger by scaling up. Let's practice scaling up a ratio with an example. Earlier, we saw that Bonnie had 2 pink marbles and 6 green marbles. Now, 2 of her friends want to join her for a game, so they all pool their marbles together. Both of Bonnie's friends have the same number of pink and green marbles as she does. What would be the ratio of the pink to green marbles in that case? There are 2 ways to figure out the final ratio. One method is to add up the total number of marbles in each group to get a new quantity to compare. In this example, we have ratios for 3 people instead of 1. So, we need to add the total number of pink marbles and the total number of green marbles from all 3 friends. When we do this, we get a total of 6 pink marbles and 18 green marbles. Now, the ratio of pink to green is 6 to 18, or 6 over 18. Another method of scaling up a ratio is to use multiplication. For one person, the ratio of pink to green marbles is 2 to 6. For 3 people, the ratio becomes larger by 3 times. To find the new ratio, all we need to do is multiply the numerator and denominator of the original ratio by 3. Make sure that you remember to multiply the numerator and denominator both by the same number. Otherwise, your new ratio will be incorrect. For the pink marbles, we get 2 times 3, which equals 6. And for green, we get 6 times 3, which is 18. So, the ratio of pink to green marbles for 3 people is 6 to 18. Now, let's talk about equivalent ratios. Equivalent ratios are just like equivalent fractions. If both the parts of a ratio are multiplied or divided by the same amount, then the original ratio and the new ratio are equivalent to each other. When we simplify a ratio or scale it up, we get equivalent ratios. In the example with Bonnie and her marbles, the original ratio was 2 to 6. When we simplified it, we got the ratio 1 to 3. When we scaled it up to include her 2 friends, we got the ratio 6 to 18. So the 3 ratios, 2 to 6, 1 to 3, and 6 to 18, are all equivalent ratios. Like a lot of math topics, we use ratios in our daily lives, sometimes without even realizing it. Let's look at a couple of examples. Kim is at the grocery store and wants to buy some fruit. This is what she ends up buying. How would she calculate the following ratios? Strawberries to oranges, strawberries to pineapples, pineapples to strawberries, oranges to pineapples, pineapples to the total number of fruits, oranges to the total number of fruits. That's a lot of ratios to calculate. But don't worry, all we need to do is follow the same steps that we learned and you'll be done in no time. For starters, let's count the number of each type of fruit that Kim bought and the total. She has 4 strawberries, 3 pineapples, and 6 oranges, which adds up to 13 pieces of fruit in total. Now that we know the numbers, let's get started on figuring out the ratios. The first one is strawberries to oranges. There are 4 strawberries and 6 oranges, which can be written as the ratio 4 to 6. But wait, this can be simplified. The numbers 4 and 6 have the greatest common factor of 2. That means we can divide both the numerator and denominator by 2, which gives us a final ratio of 2 to 3. That's all we had to do to find the first ratio. Let's answer the rest the same way. The second ratio we should find is strawberries to pineapples. There are 4 strawberries and 3 pineapples, so the ratio is 4 to 3. We can't simplify this ratio further because 4 and 3 do not have any common factors. This next ratio, pineapples to strawberries, will be easy. All we have to do is switch the order of the ratio we just found. So the ratio here is 3 to 4. Now we need to compare oranges and pineapples. There are 6 oranges and 3 pineapples. First, we'll write the ratio as 6 to 3. But wait, 6 and 3 have a greatest common factor of 3, so we can simplify the ratio. When we divide both 6 and 3 by 3, we are left with 2 and 1. So the ratio of oranges to pineapples is 2 to 1. The ratios that we've calculated so far are part-to-part ratios. The next two we need to find are part-to-whole ratios. Let's compare the number of pineapples to all the fruits we have. There are 3 pineapples and 13 fruits in total. So the ratio of pineapples to the total number of fruits is 3 to 13. This can't be simplified because 3 and 13 have no common factors. In the same way, let's find the ratio of oranges to the total number of fruits. Pause the video to give this a quick try. There are 6 oranges and 13 fruits in all. So, this ratio is 6 to 13. This also cannot be simplified, so 6 to 13 is our final answer. Great work! Here's another scenario. Leslie's cake recipe calls for 50 grams of butter and 20 grams of sugar to make one cake. Leslie wants to know, what is the ratio of butter to sugar in the recipe? And how much butter and sugar would she need to make 15 cakes? Let's start with the first part. We need 50 grams of butter and 20 grams of sugar to make one cake. The ratio of these two ingredients is 50 to 20. But we can't forget to simplify. The greatest common factor of 50 and 20 is 10. Dividing each number by 10 gives us 5 to 2. This ratio means that for every 5 parts of butter in the recipe, we need 2 parts of sugar. Let's help Leslie figure out how much butter and sugar she needs for 15 cakes. The original recipe is for 1 cake, but Leslie is baking 15. So we need to multiply the quantity of both ingredients by 15. 50 times 15 gives us 750 grams of butter, and 20 times 15 gives us 300 grams of sugar. So Leslie needs 750 grams of butter and 300 grams of sugar to make 15 cakes. And that's it! Now you know how to write ratios out for all kinds of problems. Let's move on to proportions. A proportion is an expression which states that 2 ratios are equal to each other. In math, we use the word equivalent to describe this. When 2 ratios are equivalent, they are said to be in proportion. To show that the ratios A to B and C to D are in proportion to each other, we write them like this. A to B is equal to C to D. The double colon and equal sign mean the same thing when used to write out proportions. The 2 ratios are equivalent. Proportions are extremely helpful in comparing shapes and sizes. When we say that 2 shapes are in proportion or proportional, we mean that the relative sizes are the same. For example, the head length and height of certain dog breeds are proportional. If a dog has a head length of 10 centimeters and a body length of 30 centimeters, then its height is 3 times its head length. We know that a bigger dog of the same breed with a head length of 21 centimeters would have a height of 63 centimeters because its height is still 3 times its head length. We can write out that proportion like this. 10 to 30 is proportional to 21 to 63. When setting up a proportion, make sure to write the ratios in the same order on both sides. In this example, we made sure to list the head length first and the body length second on both sides of the proportion. This is a common mistake, so always double check that your ratios are both listed in the same order on both sides of the proportion. The distance traveled by any mode of transportation is proportional to time. Consider a train that travels 300 miles in 4 hours. To find the distance the train traveled in 1 hour, we can divide 300 by 4, which is 75 miles. This means that the train covers 75 miles each hour. The proportion in this example can be written like this: 1 to 75 is proportional to 4 to 300. To understand how to represent proportions, let's remember Bonnie's pink and green marbles. She had 2 pink marbles and 6 green marbles to start. The original ratio of pink to green marbles was 2 to 6. The simplified form of this ratio is 1 to 3. We also found the scaled up version of this ratio when Bonnie's friends came along with their marbles, which was 6 to 18. In simplifying and scaling up the same ratio, we found 3 equivalent ratios: 2 to 6, 1 to 3, and 6 to 18. Since these ratios convey the same meaning, they can be expressed as proportions. Just like ratios, proportions can also be expressed using fractions. Now that we know what a proportion is, let's practice solving problems with proportions. Because a proportion always has an equal sign or a double colon, which means the same thing as an equal sign, it is essentially an equation. Just like in the equations we saw in earlier videos, we can solve for unknown numbers in proportions. For starters, consider the proportion 2 to 7 equals an unknown amount to 21. The unknown quantity is represented by the variable x. Let's solve for x. As a first step, write the proportion using fractions, like so. 2 over 7 equals x over 21. Next, multiply the numerator of the left fraction by the denominator of the right fraction. Similarly, multiply the numerator of the right fraction by the denominator of the left fraction. This process resembles a cross, so we call this cross multiplication. In this example, we multiply 2 by 21 to get 42. On the right side of the equal sign, we get 7 times x. To solve for x, we need to isolate it by getting it alone on one side of the equation. To do that, let's divide both sides of the equation by 7. On the left, we divide 42 by 7 to get 6. On the right, we simply divide 7 by 7, leaving us with 1 times x. This leaves us with 6 equals x, meaning that the unknown quantity is 6. So the complete proportion is 2 to 7 equals 6 to 21. Having learned the steps for solving problems with proportions, let's explore a real-life example. 14 feet of a metal beam weighs 42 pounds. How much does 6 feet of the same beam weigh? We can solve this as a proportion because the length of the beam is proportional to its weight. Since 14 feet weighs 42 pounds, and we need to know how much 6 feet weighs, we can set up the proportion as 14 to 42 equals 6 to an unknown value. Let's put a variable w to represent the number of pounds 6 feet weighs. First, convert this proportion to a fraction. This proportion can be written as 14 over 42 equals 6 over w. Second, cross-multiply. 14 is multiplied by w, and on the other side of the equation, we have 6 times 42, which is 252. Finally, let's isolate the variable w. To do this, we have to get rid of the 14 on the left side, so let's divide by 14 on both sides of the equation. On the right side, 252 divided by 14 would give us 18. On the left, we are left with just w. So, the value of the unknown quantity w is 18. The proportion can now be written as 14 to 42 equals 6 to 18. That means that 6 feet of the beam weighs 18 pounds. Let's try a slightly more challenging problem. A man is reading a book. He reads 2 chapters per day. Each chapter is 7 pages long. How long will it take him to finish the book if there are 476 pages in total? This problem consists of two proportions. The first is the number of chapters in the book to the total number of pages, and the second is the number of chapters read by the man to the total number of chapters. To start, let's figure out the total number of chapters. The book contains 476 pages in total with an unknown number of chapters, which we'll represent using the letter X. Each chapter contains 7 pages. We can write this as 476 to X equals 7 to 1. As usual, the next step is to convert this proportion into a fraction, giving us 476 over X equals 7 over 1. Next, we'll cross multiply on both sides of the equation to get 476 times 1 equals 7 times X. This gives us the equation 476 equals 7 times X. For the last step, we need to simplify. We can now divide by 7 on both sides of the equation to isolate the X. This gives us 476 divided by 7 equals 7x divided by 7, which simplifies to 68 equals x. So the missing number in the proportion is 68. The proportion is 476 to 68 equals 7 to 1. Now we know the total number of chapters in the book, which is 68. Since we know the number of chapters in the book, we need to find the amount of time it will take the man to finish it. The second proportion gives us a relationship between the number of chapters read and the number of days. The man reads 2 chapters per day, so we need to figure out the number of days it will take him to finish 68 chapters. How would you write this as a proportion? It can be written as 1 to 2 equals D to 68, and D representing the unknown number of days. The corresponding fraction is 1 over 2 equals D over 68. Now we cross multiply. This gives us 1 times 68 equals D times 2, which is essentially 68 equals D times 2. Since we are going to solve for D, just like our previous problems, we need to isolate the D. We can do so by dividing both sides of the equation by 2. This gives us 68 divided by 2 equals 2D divided by 2, which simplifies to 34 equals D. So the proportion is 1 to 2 equals 34 to 68, meaning the man needs 34 days to finish the book. Whew! That was quite a challenge, but taking it one step at a time, we were able to solve it. Great work! Now, you know how to use ratios and proportions. Don't forget, you can always ask a teacher or tutor to help when you need it. Thank you so much for watching this video. See you next time.